morning, guys. What's up? What's going on? Hope all is well. So, this is kind of phase two or the second part of the parallel circuit breakdown for you guys. Alright, so here we have a parallel circuit with multiple loads. As you guys can see, my VT, the applied voltage or the source voltage is 20 volts. My R1 is 80 ohms, my R2 is 100 ohms, and my R3 is 400 ohms. My third load is 400 ohms. Just by looking at the just looking at the circuit, a few things should go through your head. Number one, you have the voltage as total. Let's label that total voltage across every load. Why? Because the voltage remains the same in a series circuit, right? We know that already. Let's do that. So we'll call this V1, right? And this is going to be 50 volts. We'll call this V2. This will be 50 volts. And finally, this will be V3. This will be 50 volts. Bang, that's done. And the current will be different, right? Current will be different based on the resistance. The higher the resistance, the lower the current. And the lower the resistance, the higher the current. So just by looking at these loads, I can tell since R1 has the lowest amount of resistance, I1 will be the highest compared to I2 and I3, right? Since R1 is lowest of all the resistors, I1 will be the highest of all the currents. And since R3 is the highest of the resistance, I3 will be the lowest of all the currents. So let's move along. What should we do first? Let's find REQ first, right? Let's do that first. Now remember, REQ is your RT in a series circuit, but it's called REQ because we cannot add up all the resistors in a parallel circuit, right? So we call it REQ. We give it a new name. And the formula we're going to use is the universal formula, the inverse formula, 1 over R1 plus 1 over R2 plus 1 over R3. I like this formula because it allows us to combine multiple loads. So if I had 4 resistors, I could do 1 over R4. If I had 5, I could do 1 over R5, and so forth and so on. I could just keep moving. All right, so if I work this out, it'll look something like this. It looks something like this. 1 over R1 is what? 80. Plus 1 over 100 is R2, and R3 is 1 over 400, right? So if you work this out, you should get to 40 ohms. 40 ohms. Now this makes total sense. Why? Because we know parallel circuit facts. Parallel circuit fact says the total resistance, right here, the total resistance must be smaller than the lowest resistor. The lowest resistor here is 80 ohms, right? So my REQ is going to be lower than 80 ohms. And then I got 40 ohms, so I know I'm on the right path. I'm on the right path. Let's move on. Let's find the currents, shall we? We have all the voltages labeled. We have all the resistors there already. So let's find the current. So let's find IT first, shall we? Well, before we do that, what should we do? We should label my REQ here, right? Let's label the REQ here. My REQ is 40 ohms. Alright. Let's find IT first. IT is going to be, I'm going to just use Ohm's law here, V over R, right? Well, it's REQ, right? V over REQ. VT over REQ. My VT is 50. My REQ is 40. And my IT comes out to 1.25 amps. Guys, as you're watching the video, pause it, rewind it, right? Work this circuit out as I'm working with you. Don't just watch the video while you're just not doing anything. Pause it, work it out, and see if your answer matches my answer. Let's do I1 next. Let's do I1 next. Okay, I1 is going to be V1 over R1. My V1 is 50. My R1 is 80. Right? And what do I get for I1? Well, I got 0.625 amps or 625 milliamps. I'm going to box my answer. Alright, let's do I2 next. Let's do I2 next. Now, will I2 be higher or lower than I1? Will it be higher or lower than I1? Let's see. My V2 over R2, right? V2 over R2. That's 50 divided by 100. And what do we get? What do we get? Oh, got 0.5 amps. Oh, look at that. It's lower than I1. 500 milliamps. Oh, my bad. Should have wrote milliamps here. 500 milliamps. Right, 500 milliamps. Yeah, so it's lower than I1, right? That makes sense because R2 is higher than R1. So it's going to be lower than R1. They have current and resistance have an inverse relationship. Let's do I3 next. V3 over R3 is 50 divided by 400. Now, if the resistance is the highest here, that means my current should be the lowest here. Let's see if that's true. So what do I get? 50 divided by 400. What do I get? Get 0.125 amps, right? Or 125 milliamps. 125 milliamps. All right. Now, do these values add up to IT? You know what IT is. IT is I1 plus I2 plus I3. Now, when you add them all up, do they equal to IT? They should. Why don't you try it out and tell me what happens? All right. Next, we're going to find power. I'm going to use a different color for power. Let's find PT first. Find PT first. All right, I'm going to make it a little darker here so we can all see it. Find PT first. And I'll just use VT over IT. I mean VT times IT for this, right? The power formula V times I. That's what I'm going to use here. Right? And for your benefit, I'll use other formulas to find P1, P2, P3. Just to show you that it all works out. No matter which formula you use, you should get the same answer. Alright, so my PT is VT times IT. My VT is what, 50? 50. And my IT is how much? 1.25, right? 1.25 amps. Now I'll put this in parentheses. 1.25 amps. So what do you guys get for PT? Well, this is what I got. I got 62.5 watts. That's a decent amount of wattage right there. All right. Just yesterday, I was installing a 60-watt light bulb in my living room. So that's a decent amount of wattage. All right. So that's PT. Let's find P1, P2, and P3. All right. Now let's find P1 in the bottom here. I'm going to use I squared times R here for this guy. I squared times R. Now I'm going to use I1 and R1 because we're looking for P1, right? So the sub numbers have to match, guys. The sub numbers have to match. So what's my I1 squared? So I'm going to have 2 square 0.625. I'm going to have to square this times R1. My R1 is 80, right? My R1 is 80. And what do I get? Well, what did you get? I got 31.25 watts, right? As I said earlier, guys, you should be solving the circuits with me. So pause it, solve it, and see if your answer matches my answer. Right, let's do P2 next. Let's do P2 next. For P2, I'm going to use a different formula for P2. I'm going to use this one, V squared divided by R. All right, so since I'm looking for P2, I got to use R2, and I have to use V2. So what does that look like? My V2 is going to be 50, of course. Right, so I'm going to square this. Divided by R2. My R2 is 100. Right, and what do I get for P2? Oh, I got 25 watts. Now remember, my P1 plus P2 plus P3 should equal to 62.5 watts. Already, I know my P1 is 31.25 watts. I know my P2 is 25 watts, right, off the bat. So what can I tell? Well, I can tell that my P1 plus P2 is about 56 watts, like roughly, right? So my P3 should be 56 kind of minus 62. So what is that? That's like 5 volts or something like that. It should be around 5 to 6 volts. All right, let's see what it really is. My P3. So I'm going to use V times I here. So V3 times I3. Alright, so guys, I'm using all different formulas for these three powers. Alright, my V3 is 50 times, what's my I3? My I3 is 0.125. So my P3 is going to equal to, what is it equal to? Da 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 da. Yep, I got 6.25 watts. 6.25 watts. So 6.25 plus 25 plus 21.25, is that equal to 62.5? Yes, it does. Yes, it does. So voila. There you go. We solved the parallel circuit with three loads. And a couple of key takeaways. REQ has a new name here. It's called REQ instead of RT. New formula as well. Voltage remains the same. Current will be different. The higher the resistance, the lower the current. If one load is messed up or shorted, the other loads will still function properly. Alright? I hope that helps. And good luck. Oh, before I let you guys go, mess with this circuit for me. If you feel like you are comfortable with solving a parallel circuit, solve this guy for me, right here. Alright? R1 is 1.8K, R2 is 6K, and R3 is 9K. And your VT, your applied voltage is 27 volts. Let me know how that works out in the comment section, or if you need more assistance, just let me know what's up. Alright? Good luck. See you guys.